Good afternoon, everyone. Students, welcome to the course titled Artificial Intelligence in Industrial Management Engineering. I am Dr. Deepa Philip. I am from IIT Kanpur, and this course is offered as part of the NPTEL MOOCs course basket. And we have been in the week 4, and we were going through the lecture on sorting and searching, and why sorting and searching, or especially searching, is more important to AI. And we have just seen the binary search in a very simple example. So now let us look into other search algorithms. So if you look into the text, it is the slides, it says other search algorithms. So other major searches are, one is interpolation search. Okay. The interpolation search is like what we say, this like what people really do. Okay. So how people do the search, that's one thing called as the interpolation search. Now the other one is, the next one is indexed searching. Okay. Then we also discussed just now binary search trees. Then there is hash table searching. Okay. Then we have is Grover's algorithm. Okay. So this is waiting for quantum computers. Okay. Then we have is burst first. Okay. We also have is A star as well. Okay. So these are some of the, and the list continues. Okay. But let us just talk, and some of these searches we will actually discuss in this coming class. Okay. So let us talk about the searching problem space or the state space. Okay. So the input to this, okay, it's a set of states, okay, then operators and costs. Start state, starting point, goal state, this is the test, okay, and the output, okay, output is path, which is start to, okay, a state satisfying the goal test, satisfying the goal test. Okay. From start till a state that satisfy the goal test. Okay. It may require the shortest path. It may require shortest path, means the quickest way to reach there. Okay. An example of this is route planning. When you do route planning in Google Maps and all, this process pretty much happens in a very straightforward way. So the input is a set of states, operators along with its cost, and start state and a goal state. Output is a path from the starting state to a state that satisfies the goal test. So now let us talk about classifying the search. Okay. And I am going to, there are many ways to do this, but let us start by doing in a 3 simple fashion. So the first major thing is called guessing. Okay. Guessing. And the other way to think about it is, okay, tree search. Okay. And in the guessing, so what happens is, guess how to extend how to extend a partial solution to a problem, So, you have a problem and how to extend a partial solution to the problem. Okay. Then generate a tree of, I would say, I will put this in the bracket, partial solutions. So, generate a tree of solutions, we will call it as a partial solutions. Then the leaves of the tree, okay, are either failures means it fails the goal test, failures, or represent a complete solution. Okay. So, you start with a guess how to extend a partial solution to a problem, generate a tree of solutions, of partial solutions. The leaves of this tree is either a failure or it represents a complete solution. The second one classification is what I call a simplifying. The better word for this is inference. Okay. So, in this case, if new stronger constraints by combining, you are combining one or more constraints. Okay. Without any guessing. Okay. You have no guessing in this. You are combining or not if, infer new and stronger constraints by combining one or more constraints. So, let us take an example and to understand this. Okay. We can say all apples are fruit. Okay. This is a true statement. All bananas are fruit. This is also a true statement. Okay. If you say therefore, you are inferring. Okay. This is the inference, or you are inferring this. Therefore, all bananas are apples. If you infer this, this is false. Okay. So, the inference is more like a simplification aspect. Okay. If you see small kids, they see an elephant with 4 legs and then you show a cow, it will say elephant. Okay. So, that is the kind of thing what we are talking about. The third one is what we call as, the third approach is wandering. Okay. Or in this we will call it as Markov chain. Okay. So, we will say that perform a random walk, okay, through the space of solutions. So, you perform a random walk through the space of the solutions. These are partial or total. You walk through the space of the partial solutions, okay, and you perform a random walk through the solution space. So, these are the three main ways to classify this. Okay. So, let us give a little bit more meat to this problem. So, in guessing, okay, state space search, okay, So, some of the main ones: breadth first search, depth first search. So, this is known as BFS, this is known as DFS. Okay. Then 3, iterative deepening. 4, bidirectional search. Okay. 5, best first search. Okay. The BFS is not best first, it is breadth first. Okay. Then 6 is A star. 7, game tree. I am giving some examples. We will cover some of this in the class, but the rest of it for you guys to do. Okay. And the one is Davis-Putnam. This is logic. Okay. Davis-Putnam. Then cut set conditioning. This is also probability. Okay. So, this is the guessing, some of the main things as part of guessing. So, you can go through all of these. Okay. Now, let us talk about simplification, okay, which is another thing about is constrained propagation. Okay. So, some examples of this is forward checking, forward chaining, forward checking. Okay. Then path consistency, okay. This is Walls labeling or temporal algebra, but let us call it as path consistency, resolution. Fourth is bucket algorithm. So, you could find materials of these things easily, and we would expect that you will go through this and identify, right. Then is the, we talked about as wandering, okay, which is randomized search. Remember, we talked about random walk. Okay. So, number 1 is hill climbing, number 2 is simulated annealing, number 3 is walk sat. Then 4 is also Monte Carlo methods. We have studied Monte Carlos in my other courses as well. So, these are the some major examples of how the search can be, or different algorithms that are available as part of the search. So, please, the thing you have to do is, okay, go through and familiarize all. Okay. So, you have to go through and familiarize all of them as part of this course. Now, let us talk about what we call as search strategies. Okay. What are some of the search strategies, and let us put it as there is, I would probably say there are 4 major strategies. Okay. The first strategy is the blind search. Okay. So, the blind search is, let us say, I would call the first one is as the depth first search. As we mentioned earlier, maintain a stack of nodes to visits. Okay. Then breadth first search. In this, maintain a queue. Instead of a stack, you are maintaining a queue of nodes to visit. Okay. Then iterative deepening search. Okay. It is depth first search with limit. Okay. Incrementally grow the limit. Grow the limit. So, you do not go to the end of the depth of the tree. You will, there is a depth first, but you put a limit and incrementally grow the limit. Okay. And then similarly, iterative broadening search. That is the other. So, these are the 4 blind search, because lot of the searches that you see are the blind searches. Okay. Then comes the next one, informed search. Okay. We will get into more details about this in the following slides. Then we call it as constraint satisfaction, already seen that. Okay. How do you do a constraint satisfaction, constraint propagation, etc. Then you have is the adversary search. Okay. So, these are the 4 major search strategies. Okay. Blind search, informed search, constraint satisfaction, adversary search. So, there is also a problem with the simple search. As everybody, we said blind search or simple search, they are very good. I mean, they are very popular. Okay. But there are major problems. All these methods, the simple search methods, all these methods are slow. Why they are slow? Because they are blind. Okay. That is why hence blind search, SEARCH, implies simple search. Okay. So, what is the solution to this? What is the solution? Okay. The solution is add guidance. Okay. Add guidance. Okay. You should add guidance, or known as heuristic estimate. Should add some guidance, should add, tell the blind search where to go, right. So, this is also known as informed, other option is informed search. Okay. Instead of the blind search, do informed search. Okay. So, it is a second alternative to it. You can add guidance or you can do the informed search. All right. And let us go to more on search. Let us think a little bit more about the search. Okay. So, in this we can say that we have some actions, that can change, the state of the world, Okay. So, you can have some actions that can change the state of the world. Okay. Change induced by an action. Okay. If the change is induced by an action, it is perfectly predictable. Okay. So, if you are inducing the change by an action, then it is perfectly predictable. Then try to come up with a sequence, of actions. You are trying to come up with a sequence of actions that will lead us to the goal state, that will lead us to a goal state. Okay. The sequence of actions, we are trying to come up with the sequence of action that will take us to the goal state. Okay. Then you can say you may want to minimize the number of actions. Okay. You may want to minimize the number of actions. More generally, okay, may want to, instead of minimizing the number of actions, you may want to minimize total cost of action. Okay. Whatever those actions that you talk about that results in the state space, goal state, you may want to minimize the total cost of the actions instead of minimizing the number of the actions. Okay. So, which means what? Do not need to execute all actions or execute actions in real life while searching for the solution. While searching for the solution. Okay. Do not need to execute all actions in real life while searching for the solution. Okay. That is because it can be predictable anyway. Right. All right. So, this is the some aspects of the search. So, let us understand this with a simple example. Okay. Let us take a simple example and try to find out what it is. So, here is I am trying to create a network A. This is the start state, okay, A, and then you have B somewhere here, okay, and then you have C somewhere here, and you can go from B to C, and you can also go from C to A, okay, and then you have a, let us put a D here, okay, and then you have a E here, and you have an F here, okay, and F is your goal state. So, state is the condition in which, and in each one of these you have a cost associated or you have something to spend. Okay. So, from A to B, if you do move, it takes you 3, you have to spend 3 time units or $3, whatever it is. B to C it takes 2, C to A it takes 2, A to D it takes 3, D to E it takes 4, E to F it takes 4, and B to F takes 9. Okay. So, this is the whole thing. So, your aim is to start at A. Okay. So, you are saying start here, okay. This is reach here. Okay. So, how do you search the tree? Okay. So, let us give a simple example out of this. Okay. So, your starting is A. So, I am doing the first node, okay. State is equal to A, cost is equal to 0, you have nothing, okay. I just started here. Then if you look into it, from A you can go to 2 places only, B or D, okay. So, your tree will have 2 branches, okay. That is, one branch is here, okay, which is this, and the other branch is here, which is this, okay. And one is, if you go back, state is B, other is state is D. So, this is the state equals B and cost is equal to 3. Where did I get the cost from? This cost is 3, okay. This is the cost. Okay. Now, in this case D state equal to D, cost equal to 3. Where did I get the cost equal to 3? It is this line, okay, cost equal to 3. Now what happens is, let us take B from here. From B, I can go to two places. I can go to C, or I can go to F. Okay. So, I have 2 here. Okay. Okay. One is state is equal to C, which is from B I can go to C with a cost of 2. Okay. So, the cost is equal to 3 plus 2, which is equal to 5. Okay. The other one is I can go from B to F. Okay. So, state is equal to F and cost is equal to, if I go there, it is 3 plus 9. Okay. So, cost is equal to 3 plus 9, which is equal to 12. Okay. But when I reach here, F is my goal state. Okay. I reach the goal, right. So, then at C, when I reach C, what will happen? From C I can only go to A, right. So, below C I am just drawing that, okay, just to make your life easy. Okay. This is state equal to A, and if I reach A, what is the cost? This is 2, okay, add 2 with this, that is cost is equal to 5 plus 2, that is equal to 7. Okay. So, you come back to state A and then you repeat this. Okay. I can still continue to expand all of these things and then go from there, but I have reached the goal, but to reach the goal I have spent what you call as 12. Okay. Now, the question here is this the best, or in another way is, did we minimize total cost? Okay. So, that to do that we have to find out, we have to expand the tree, right. Then what is that full search tree, okay, in this regard? So, let us try to expand that full search tree and go through this. So, as I said earlier, we started at state equal to A, cost is equal to 0, you had 2 here like this, okay, that is state equals B, the cost was equal to 3, state equals D, cost was equal to 3, we did this earlier. Then below B we had 2, okay. B had state equals C, the cost was equal to 5 and state equals F, cost is equal to 12, and this we label it as a goal state, okay. And we also did under C, it was, we said state equals A, cost equals 7, and then under D you can see that D I can go to only E, okay. So, D and with a cost of 4 units. At D I have is a state equals E, cost is equal to 3 plus 4 equals 7, okay. So, that is the, we have reached the E as part of it. Now, from E I can go to one more only, which is F, okay. From E I can go to F, this is the other unit of 4, okay. So, state equal to F, cost is equal to 7 plus 4, okay. I think it was 4, it's 4 equals 11, okay, and you see that this is a goal state, okay, you reach the goal there as well. Now, what happens next here is when you reach A, what will happen here? At A, you will have 2 branches, okay, one is state equals B, okay, and the cost is equal to 7 plus 3, which is 10. Here is state equals D, cost is equal to 7 plus 3, that is equal to 10, and you can see that, okay, this is the repetition of the tree. Okay. You are now doing the, so what has happened is you have started here, you went to B, then you went to here, then you went to here, and now you are repeating the whole process. So, that is what this portion of the tree shows. But you can see that you can go from, in this case now if you look into it, the A to B to F, okay, cost is equal to 12, A to D to E to F, the cost is equal to 11. So, the better is, okay, you would like to choose this because it is total cost is less or minimum. Okay. So, that is the reason why you would end up preferring to use this. So, with this we will come to a stop at this point, or work on another example later down the road to see how this actually would proceed. So, thank you for your patient hearing, and we will continue in the next class. Thank you.